we will start our new unit after you guys did your explore activity and worked on Twig. I'm just going to sum up what you probably learned and the observations you made from these assignments. All right, so the title of the new unit is Newton's Law or Laws. All right, and we will start with Newton's first law of motion. So what we learned in the previous unit, we learned about motion and graphs and motions and time, velocity, and distance. So in other words, we described, so in the previous unit, we described motion, right? It was the previous unit. We described motion, all right? Given graphs, tables, diagrams, numbers, and all that stuff, all right? In this unit, we will explain and discuss on how motion itself is explained and how motion itself is done. All right, so first, it's really good to know that Isaac Newton, that was back in the 17th century, and now we're in the 21st century, so 400 years ago, Isaac Newton th century scientist found or discovered the three laws, and that's why they're called Newton. The three laws known as Newton's law. So this is just a little background of how they got Newton's law. All right, so the first law of motion is known as law of inertia. And what it means by that, it means that an object is at rest, will stay at rest. So if there's an object not moving, it's just going to stay not moving. And an object in motion is going to stay in motion with the same direction and the same speed, unless there is a force acted upon that object. So let's just summarize this. Newton's first law So, just looking for my purple. Newton's first law is also known as law of inertia. Wait, I'm missing something. TIA. All right. And what we mean by that, we mean an object. So let me highlight And what do we mean by that? I mean that an object at rest stays at rest and an object in motion stays in motion with the same speed and it has to be in the same direction. Unless acted upon by an unbalanced force. So if there was a change in the direction of the object or the speed of the object, that means this is not law of inertia anymore. That means the Newton's first law does not apply to the object anymore. Right? So in other words, we have two very important statements, all right, that will summarize Newton's first law. So forces, so when we said unless acted upon by an unbalanced force, right? So what is then the forces that are balanced? So when we talk about forces that are balanced or balanced forces, we are referring to two important clause or statements. First one is the object at rest. What do we mean when we say object at rest? It means the velocity is 0 meters per second and there is no change in velocity or speed. That means your acceleration is 0 meters per second squared, and this will keep my object stay at rest. Okay? All right, what is the other condition? Or the statement, I should say. Objects in motion. So how is this translated when objects are in motion? That means their speed is not equal to 0. Oops, it should be just 1. Does not equal to 0 meters per second. However, there should be no change in the speed. So your acceleration should be 0 meters per second squared. And that will mean that it will stay in motion, but with the same speed and direction. Okay? So in other words, the most important thing is that the acceleration is 0. Whether I have an object at rest, which means your speed, your velocity is 0 meters per second, or if I have a speed that is not equal to 0, which means an object is in motion, but I have no change in speed, which means your acceleration is 0, then these are the forces that are balanced, which will apply the law of inertia, or Newton's first law. Okay, so let's say an object is moving 5 meters per second east, then this is first law, first Newton's law, or Newton's first law. If the object is moving 5 meters per second east, and then in like after 5 minutes, they turned and, they went to the west, then we know that we are not talking about Newton's first law anymore, because there was a change in the direction and the speed. Okay? So there really, as you guys did in your explore activity, that you will see the Newton's first law of motion in a lot of our everyday life. As you know, physics is just the science of the universe. So everything around us, it's all about physics. Even the sound the way you hear me, the frequency, the light, the bulb, everything is physics around you. All right. So the question would be, have you ever experienced inertia? I'm sure you've done that, right? So if we talk about an example, let's say the force, so let's say you're driving a car and, you were just driving at a constant speed, and then you hit the brakes because the wheels got stuck on whatever, something in the road that made that friction slow down your car, right? So first you were really just going in a constant speed. That's Newton's first law of motion. And then that's because there was no change in velocity. But now, as you slow down, now you know that what has happened to you is that change in acceleration or speed, the change in speed causes the acceleration or the deceleration in this case. Now you do not have, you have an unbalanced force now. Okay, so this law does not apply anymore. All right, let me just sum up what I just said. So Newton's first law of motion states that an object stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon I know I've wrote this before, but by an unbalanced force. So, in other words, objects keep doing what they are doing in the same state of motion. All right. So in other words, inertia is the resistance an object has to change to change. Okay, wait. The resistance an object has to change in its state of motion. Okay? Uh, so what was believed in physics is that moving object would eventually stop moving, right? Uh, so the best thing to do it is, if you want this thing to keep going, that means we need to give it more force. So for it to keep moving, all right? And then, all right, so which means Newton's law of motion. Let me just write down what I just said. So Newton's first law of motion declares that a force is not needed to keep an object in motion. So in other words, if I slide this book, I pushed it, but if let's say I slide it, even though I was not giving it all the push, so it stopped. It stopped a while after I stopped that force on that book. Okay, so the book actually started at rest, and then it slid. So there was no force needed to keep an object in the same motion. Okay, and usually the more heavy or the more massive the object is, the more the object resists the change. So if that book was heavier, it would have been hard, which is more massive, it will be harder for me to, not harder, but the force will be less effective than how it was when I pushed it with the less mass. All right, so we're just gonna write this down. It's it's a concept. Yeah, the more here. So just gonna see how I'm gonna word it. Um, Okay, so let's do this some examples. So imagine a place in the cosmos far from all gravitational and frictional influences. Okay? And suppose that you visit that place and you're going to just throw a rock. What would happen to the rock? Just throw it. So the rock will continue in motion in the same direction at constant speed. So that's based on according to Newton's first law. Just do example 1 here. Okay, so when you throw that object and you just leave it, it will just continue to go in motion. Let's do example 2. A 2-kilogram object is moving horizontally with a speed of 4 meters per second. How much net force is required to keep the object moving at this speed and in this direction? All right, so we have the object is moving horizontally. That's the object moving. And it's the mass is 2 kilograms. Speed is 4 meters per second. So what is the net force? So this object is in motion, right? Does it say anywhere that this object was given another force or a push? It does not say that, right? Which means there was an object will maintain the same. That means an object in motion. Let's just write this. An object in motion will maintain its state of motion so there is the presence of an unbalanced force changes the velocity of the object, which means the force will be 0 Newton. There is no force acted upon the object. Okay? So let's do a few more examples. Let's do example 3. All right, so let's suppose you were in space. In a weightless environment. Do you think it would require a force to set an object in motion? Would it require a force to set an object in motion? So, what do you think? Absolutely yes, definitely. Why is that? Because even in space, objects have masses, right? So even in space, remember you always have to do your CER. So when you explain something, when you say yes or no, you have to explain it. So even in space, objects have mass. And if they have mass, they have inertia. So which means an object in space resists changes in the state of motion changes in the state of motion. So as we know from Newton's law that a force must be applied to set a stationary object in motion, which is, so here the answer will be yes. Newton's law everywhere. Okay? So this is pretty much summing up what the explore activity that you guys have done. So this is gonna be it for this video. I will have more videos for you, but I just don't want to keep the videos too long so that they're not laggy or glitchy.